Okay, I've got more exciting word problems for you today. And I know what you're thinking. You're thinking, Mr. Gilchrist, this isn't fair. We just started this chapter. We just started this class, and you're giving us so many word problems. Yeah, get over it. You have to be able to do word problems because that's all there is. You know, there's no job out there where somebody's just going to give you a worksheet of problems for you to solve with numbers. It's like whenever you're actually going to be using math, you'll be taking numbers that you either have to make sense of that were given to you from some other person, or all jobs are word problem jobs at some level. So we have to practice them. We're going to do 4 examples: mixing chemicals, chasing runaway friends, swimming upstream. This is actually going to be a boat going upstream, but whatever. And then doubling things. I had this at the end of the last video. Most problems set up one of 2 ways, either side by side when you're mixing stuff together, where you have something plus something equals something, and then a coefficient like a percent of something or an amount of something plus percent of something equals the percent of the something. It often has just a plain old xy equals something, then a coefficient on those things. Or if you have an independent variable, if you have a slope or a rate, you have 2 different scenarios, and you compare the 2 scenarios. These are the 2 main ways to set up word problems. We did a problem like this on the last video. A chemist needs a solution that is 30 milliliters of 16% acid. And solution just means a fluid, a liquid. So 30 milliliters of 16% acid. She has an unlimited supply of 10% acid and 40% acid solutions. How much of these 2 solutions should she combine to result in the desired mixture? Before we start, A, pause it to see if you understand the problem, maybe read it a few times, but B, ask yourself the question, is it going to take more of the weak stuff or more of the strong stuff? So pause it and do those 2 things, please. It's going to take more of the weak stuff because 16 is closer to 10 than it is to 40. In fact, this is going to be a very similar answer to the last problem that we did in the last video because the percentages are about the same distance, but that's okay, I'm not too worried about that. What are we trying to find? We're trying to find milliliters needed of the 10% stuff. That word is acid there. And we're trying to find milliliters needed of the 40% acid. Those are our 2 variables. I'm going to show 2 ways to do this problem this time. Last time I just showed one, this time I'll show another. Some of you will prefer the second method, some of you really won't. We know that x plus y has to equal 30. All in all, we need 30 milliliters. We also know that we have 10% acid, and we have 40% acid, and altogether we want 16% acid. And so this problem is setting up in this form over here, which I just made really small, and I'll go back to regular. Very often people forget to do 0.16 times 30. This is the most commonly missed part of this problem. It's 10% of this, and 40% of this, and 16% of this. So please don't miss that. Now I can solve this by substitution or elimination, or I could graph it also. In fact, if you just plug this into Desmos and graph it, you could find a solution pretty quickly. But I'm going to go through and do this by, I think, elimination again. I'm going to clear the fractions, or in this case, the decimals. So I'm going to multiply everything by 100. Why do I use that dark blue? Come on, Grant, you know better than that. And that's going to give me 10x plus 40y equals 0.16 times 30 was 4.8. Times 100 is 480. So I could have done by 10. I should have done by 10. Let's just do it. Whatever, we'll live with it. Then I'm also going to have x plus y equals 30. I really prefer elimination because I just think it cleans itself up real nicely. So I'm going to multiply the top and the bottom here by negative 10. Sorry, not top and bottom, the left and right side of this equation. I'll multiply this by negative 10. So I get negative 10x minus 10y equals negative 300, and 10x plus 40y equals 480. I add these up and I get 30y equals 180. Whoa, this is going to work out really nice. Y comes out to 6. I did not mean for that to come out so pretty, but it did, and I'm okay with that. If y is going to be 6, then x is going to be 24. I got that by plugging a 6 in right up here. Because x plus 6 has to equal 30, so x is going to be 24. Now this seems further apart than I thought they were going to be. I thought they were going to be closer together. So I'm going to check this to see if it actually gets me the right percentages. If I do 0.1 times x, and x is 24, I'm plugging things into this equation here. I plug stuff into here. And 0.4 times y, and y was 6. This gets me that. That is hopefully the same as 0.16 times 30, and it is. So it checks. You should always check your answer. Again, if you set up the equations wrong, you have no hope of getting the check right in the first place. But if you set up your equations wrong, you probably can't get the problem right to begin with anyways, unless you can go back and find your mistake. It's good that this had more weak stuff than strong stuff. Yeah, I guess halfway between 10 and 40 is actually 25. And 16 is fairly far from 25. 25 is halfway in between, so it's much, much closer to the weak stuff than the strong stuff, so it makes sense it'd be split up that way. Okay, so I was going to show two ways. Here's the other way. This is the way that most people would show it the first time, probably. Actually, no, probably the second time or third time. But here we go. Let's say that X represents the milliliters of 10% acid. Instead of saying Y as the milliliters of 40% acid, there's actually something else that we know. I could express the amount of 40% needed as Y, but I could also express it as 30 minus X. Okay, if I know how much 10% I have, and I don't know, but I'm going to call it X so I can represent it as X. If I'm going to call that X, I know that X plus Y had to equal 30. So really, Y must equal 30 minus X. And had I ever solved this by substitution, that would have been the first thing we'd done. Subtracted X from both sides to get Y equals 30 minus X, and taken this and plugged it in there. And that's a fine way of doing it, but we can also just start there. If X is going to represent the milliliters of 10% acid, 30 minus X is the milliliters of 40% acid. Think of it this way. If X is 10, Y has to be 20, because they have to add up to 30. And if X is 5, Y is 25. And if X is 12, Y is 18. And if X is 0, Y is 30. And if X is X, then Y has to be 30 minus X. So I can do this with just one variable. And now I have to set up my percent equation, okay? So I'm going to see how much acid is in the first one. That's how much acid is in the first one. How much acid is in the second one? It's going to be times 0.4. Didn't give myself enough room for that. And all this put together has to be 16% times 30. I can just set up this one equation. And I think this takes a higher level of understanding. I don't think that this part is necessarily obvious, and then this is no different than just how we would have set up this over here, which is now getting very, very confusing with all the colors on it. But if you can follow this method, it's definitely a quick and fast way to solve. Now we just have one variable and one equation, and we just solve. 0.1x plus 1.2 minus 0.4x equals 4.8. I just distributed the 0.4 here. So now we get negative 0.3x equals 3.6. I divided. Now I'll show the steps here better. I did two steps at once, but I'll spread them out. First I'm going to subtract 1.2 from both sides. So now I get 0.1x minus 0.4x equals 3.6. Then I'll combine these two things. That's 0.3x. I'm going too fast. I'm going to slow down. I'm going to actually put these two things together. 0.1x minus 0.4x is negative 0.3x. Divide both sides by... and that's a problem. Because this shouldn't be coming out negative. If it comes out negative, something is definitely wrong. So where did I go wrong? 0.4 times 30 is not 1.2. 0.4 times 30 is 12. Here. This was 12. I don't actually mind making mistakes. Like, I could go back and stop and redo this and actually have a few times on other videos. But I think it's good for you to see me make a mistake and see me fix it. So 0.1x plus 12 minus 0.4x equals 4.8. Subtract the 12 from both sides, and we get 0.1x minus 0.4x equals 7.2, negative 7.2. So I combine these two things, negative 0.3x equals 7.2. 7 equals negative 7.2. Divide both sides by negative 0.3. And that's 24. So it takes 24 of the weak stuff, which is going to give us 6 of the strong stuff, just like we had before. So apart from a couple arithmetic errors, that's the other way to set this up. And there are other ways. Some books and teachers will use this little box method, where they have like percent times amount equals quantity, and they'll put numbers here and variables here and set up the system of boxes. If you think that would help you and want to follow that, you can just find a video that does that. I'm not going to. But some people like that level of structure, so you can track that down. But these are the two ways that I'm going to show and stick with. Next, your friend is running away from you. You're going to catch her. She's running because she doesn't really like you, and you basically kidnapped her to make her play Monopoly with you, and you don't really have any good snacks anyways. But that's all beside the point. She has a 200-foot head start and is running at 12 miles per hour. If you run at 15 miles per hour, how long will it take you to catch her, and how far will you have ran? Well, first of all, as much fun as this stuff is, it doesn't matter. Let's just get rid of all this. In fact, even this, actually the fact that she's running away from you, this does matter, so I'm not going to delete that. That does matter. She is running away from you. She has a 200-foot head start and is running at 12 miles per hour. Well, this is different than two trains heading towards each other. We did two trains that were heading towards each other, and they smacked into each other, or at least they met somewhere. This is the opposite. She is ahead of you, running, but you are running faster. So you're going to gain on her eventually. But while you're running towards her, she is also moving. So she's doing this while you're doing this. And as she keeps going, you keep gaining on her. And eventually, you will catch her. The question becomes when. Well, this is another two-scenario problem. There's you and there's her. So let's talk about her. Her distance is going to be given by the equation 12x plus, and I can't actually write a 200 here. She has a 200-foot head start. But this was written in 12 miles per hour. So if I wrote a 200 here, that would mean 200 miles. And she is not 200 miles ahead of you. She is 200 feet ahead of you. So the way that we have to express that is in terms of miles. 200 feet is 5,280ths of a mile. Because there's 5,280 feet in a mile. That is her head start. This number right here represents her head start, how far ahead she is. It's the y-intercept in y equals mx plus b. Her slope is 12. Her b is 200 over 5,280. And we can use that to find her distance. So for example, say it took us an hour to catch her. Well, that would be, she'd tack on 36 miles. It would be 36 miles plus whatever else there was in there. So that is her equation and her head start. Her distance equals her rate times her time plus her head start. You are just going at 15x. And you want to catch her. Now, if you think about that train problem, in the train problem we had one of these numbers as negative. And the train problem, one of them had a negative slope. We did that because they were going in opposite directions. One was going forwards, as we called it, and one was going backwards. And the one that was going backwards had a negative direction. But in this case, we're both going in the same direction, so they're both going to be positive. The good news is we're catching her, we're going faster. I can solve this by substitution. I want to know when are the two distances the same. When does her distance equal my distance? Because then we'd be at the same point and I would have caught her. So I substitute. 15x equals 12x plus whatever that fraction is. I'm going to reduce it on my calculator. If I do 200 divided by 5,280, I get this. On this calculator, I can press the math button, and the first option is arrow frac. It's 5 and 1/32. So you can either write 0.4 miles. In fact, I'll just do 0.04 miles, I think, to make it simpler, 0.04. And there would be the fraction. Let's just call this plus 0.04. So she's 0.04 miles. It turns out that that 200 feet is not going to make that big of a difference in terms of how long it takes us to catch her. Now we solve, subtract 12x from both sides. You get 3x equals 0.04. Divide both sides by 3, and I'll get x. 0.012 hours. Let's make that minutes. 0.75 minutes. Let's make that seconds. Should be 45 seconds. Yeah, 45 seconds. Now that doesn't seem like very long, but 200 feet is not a huge head start. You know, it's halfway around a lap on a track. And going 3 miles an hour faster is actually going 15,000, almost 16,000 feet per hour faster. And we want to make that feet per second. You're going 4.4 feet per second faster. It takes you 45 seconds to catch up, to make up those 200 feet she's ahead. It actually makes perfect sense if you think about it. Now, I want to kind of analyze this a little bit. Since you're running towards her, and you're running 3 miles per hour faster, you only have to make up 0.04 miles. These are actually the two numbers that matter. If you're going 3 miles an hour faster and have to make up 0.04 miles, you just do 0.04 divided by 3. And that's exactly what this showed, right? Like this right here, I'll even circle it better. This got us to 3 miles an hour faster. 15 minus 12 is 3 miles an hour faster. Then this was how much time it takes up to make up those 0.04 miles. So this substitution method got us the same thing, but you can also just think about it this way. You're going 3 miles an hour faster, you have to make up that many miles, how long does it take? And that actually accounts for the fact that she's running while you're running. That accounts for the fact that as you're chasing her, she's moving. Like if she was standing still, you'd catch her really fast. But as you run towards her, she's running, you're just gaining on her little by little, and we can ask Zeno if you ever actually get there, but that's another conversation. Last one. This is another very common problem, especially these days. I've seen a lot of textbooks lately. There's a boat going upstream and downstream. It takes the boat 5 hours to travel 200 miles upstream, but can make the same trip downstream in only 4 hours. So why does it take longer going upstream than downstream? Because going upstream, the current is fighting you, and going downstream, the current is helping you. So we're still doing distance equals rate times time, and there's still going to be two scenarios. There's going to be an upstream scenario and a downstream scenario. And the distance doesn't change. In either scenario, the distance is 200. And the times are known. In the upstream scenario, the time was 5 hours, and the downstream scenario, the time was 4 hours. What changes is the rates. And the rate here becomes pretty interesting, because there's really two things we're trying to find. I broke my rule. I should have done this first. X is going to stand for speed of boat. Speed of boat in still water. I should have started here. Define your variables. Y is going to stand for the speed of the current. And here's the important thing to understand. If you're going upstream, the speed of the current is taking away from the speed of the boat. They're fighting each other. So this is your rate, right? Your rate is the speed of the current taking away from the speed of the boat. But if you're going downstream, they help each other. The speed of the current is helping the speed of the boat. So we still have two variables and two equations, but it's interesting how this rate changes. When you're going upstream, you're going slower because these things are fighting each other. When you're going downstream, you're going faster because these things are helping each other. If you've ever swam in a river or in a pool that's got like a wave or a current to it, or in the ocean, you can kind of feel that if you can move with the tide or move with the river. Now, solving this, I really recommend you don't distribute. You can distribute the 5 and the 4, but what you're going to find to be much quicker is divide both sides by this 5 and divide both sides by this 4. That's going to get you an elimination setup that's really nice. You get 40 equals x minus y, and you get 50 equals x plus y. Then you add up these two equations because the y's are going to cancel. And don't do this too haphazardly. People make a mistake here. X plus x is 2x, not just 1x. X plus x is 2x. 40 plus 50 is 90, and the y's are gone. Divide both sides by 2. X equals 45. The boat can go 45 miles per hour, which is pretty fast. I mean, not crazy fast, but pretty fast. If the boat's going 45 miles per hour, we can plug that into any of these equations. The river is going 5 miles an hour. Boat goes 45, river goes 5, makes perfect sense. A lot of students like to do this differently. They will just average the two things and then go up and down a little bit. You can find a way of doing it that way if you'd like to. Take an average and then find the distance between the two things and the endpoints. And if you want to try it that way, go ahead, that's fine. I'm not going to show it that way. This is how you set up the equations, and this is how the solving happens. X is 45, y is 5. Finally, and this is a problem that was, not this exact problem, but a scenario in here was asked to a lot of math teachers, and most of them got it wrong. At the sausage conference, there are twice as many men as women. If there are 444 people total, how many men and how many women are at the conference? So we're going to make X stand for number of men, and Y stand for number of women. Try and set up equations, please. Pause and set up equations. And you're wrong. Probably. I don't actually know that. Most of you probably wrote this. You wrote that because there's twice as many men as women. And so you figured 2x equals y because there's twice as many men as women. But I'm going to show you that it's actually this. Let me try and convince you of that. Here's a table showing the number of men and the number of women. Let's say there were 10 men present. And I know there's not 10, there's not going to be 10, but pretend there was 10. If we have twice as many men as women, and I'll even just label X and Y as men and women. If there's twice as many men as women, how many women are there? Well, there must be 5. And if there was 100 men, there'd be 50 women. And if there was 12 men, there'd be 6 women. And if there were 3 women, there'd be 6 men. And if there were 18 women, there'd be 36 men. And if there were Y women, there would be 2x, no, the other way around, there'd be half x. So I'll do it this way. If there were X men, X-Men, yeah, X-Men, right, Cyclops, there would be 2Y women. To make this side equal this side, you have to multiply the right side, the Y column, the women, by 2. Remember that equals means same. So to make the number of women match the number of men, we have to multiply the number of women times 2. And I'll try and illustrate this like with feet. We know that 3 feet equals 1 yard. Okay? And this is measuring distance. The left side is a distance, the right side is a distance. To make this distance the same as this distance, well, these are same distances. 3 feet equals 1 yard. But if I was going to do like the number of feet compared to the number of yards, all of a sudden it's different. Because say I had this length, and we're going to say that length is 36 inches. So I have that length. Well, the number of feet it would take to get there is 1, 2, 3. It would take 3 feet to get there. To make the number of yards match the number of feet, not the distance, but the number. To make the number of yards match the number of feet, we'd have to do 3 times the yards to equal the 1 of the foot. And that's the difference between having a number of something and a measure of something. Okay, the number of women, this might have confused you, so you can ignore this if you want. The number of women has to be doubled to match the number of men because we want them to actually be equal to each other. So it's not this one, it's this one. The number of women has to be doubled to equal the number of men. And that type of problem was posed to a lot of math teachers and professors, and most of them got it wrong because at first it seems like it should be this one. So there's one of our equations, x equals 2y. The other equation is x plus y equals 444, because the number of women plus the number of men was 444. I will now substitute. I will take this 2y and plug it in for this x. So 3y equals 444. 444 can actually be divided by 3 very cleanly. We get 148. So if y equals 148, x is going to be twice as big as that, which is going to be 296. Whew! Another set of word problems. Thanks for bearing with me. Have a nice day. Hey, thanks for watching. I hope that was helpful. If you have any questions, leave them in the comments down below. There can be questions about the video you saw here or anything else in math I'm happy to help with. Subscribe if you'd like to watch more videos. Or see other updates as they come. I'm going to try to run through all of Algebra 2 Trig and then eventually hit more classes like Algebra 1 and Geometry and Pre-Calc and everything else. If you have questions about stuff covered that's not in this video, still let me know. I'm happy to help. And finally, if you're not one of my students taking the class, but you found the video and are watching it, or maybe you're a teacher and are watching it, you can buy the curriculum and buy the worksheets to go through it. That's found at the website listed down below also. So again, thanks for watching. Have a wonderful day.